thanks to everyone at Microsol for inviting me here today and for setting this up, and it's great to see such a great attendance at it. I hope I'll be able to share some useful information for you on the 2030 challenge, yeah, so these things are always fun with you guys, so thanks again for setting it up. Okay, so I've got a few slides just to talk about the 2030 challenge and sort of set the level. Some of you may already be familiar with a lot of this, and I think there's some information in here that will be new to you as well, because it's information that based on some research that we've done ourselves. And then also I'm going to give you a little demonstration of Insight and Revit, how it works with Revit, and how you can use it to submit to the 2030 commitment. Okay, so we'll also leave time for questions at the end. We should mention that also. So first of all, the 2030 challenge. It's essentially a series of stepped goals, essentially moving towards carbon neutrality for all new buildings and major renovations by 2030. And this has been around for a while, and every 5 years the targets get higher. So currently today, in the current period, we're at 70%, and that's essentially 70% above a 2003 baseline, so a baseline that was set in 2003. So the targets aren't moving, they're sort of set in stone. They're very specific energy use intensity targets, which we can get into a little bit. But it's very aggressive, but it is also very achievable as well, like as we will be able to show you here today. So that's it. Essentially, the Architecture 2030 group, 2030.org, they're essentially responsible for this. So Ed Masri and his team essentially were the brain trust behind this, and we're big fans of theirs. And they've essentially been calling the building industry to look to reach to these targets, and to designers to strive for these goals, whether your client is essentially asking for high performance or not. Do your best to meet the goals. Now, the 2030 group have got a number of different initiatives. This is probably one of their signature ones, one of the main ones that really every other thing is sort of supporting this. And in addition to this, and I'm going to be talking a lot about today, is actually another thing called the 2030 commitment, because it essentially supports the 2030 challenge. And for our customers and for especially architects and engineers, this is something of real value that really helps track progress towards the 2030 challenge. People often confuse the two, the 2030 challenge and the 2030 commitment. It's actually really simple. The 2030 challenge are the goals, and the 2030 commitment is essentially this. It's a national framework with some simple metrics and a standardized reporting format to provide a structure for tracking progress to help meet the 2030 challenge. And if you go to the AIA's own website, you'll see that they've got a number of different resources there for you. First of all, if you're not already a signatory, you can sign up. There's a number of training resources. They produce an annual report every year, which I'm going to be sharing some information on, so you see where we're at with the state of the industry and also some of the challenges that people are having and opportunities. Also critically, the 2030 DDX, or data exchange, design data exchange. That's where all of the annual reporting is essentially taking place as an online resource, and we've made a connection to that tool with Insight that I'm going to show you, and you'll be able to see how you can speed up that process. So that's essentially the 2030 challenge and the 2030 commitment, and the AIA are really putting a lot of weight behind this. They continue to promote it and produce a report every year so that we can see in entirety how we're doing as an industry tracking towards these goals. So they've been producing this report for about 6 years, I think now, and I'm going to share some data with you from the most recent report, which is 2015, and you'll see sort of where things are at. And if you've been reporting yourself, you'll be able to measure where your firm is at relative to the broader industry. And we'll talk a little bit about that as well in this webinar, about the value of this data, because it's something that's sort of been a little bit overlooked by people at the moment. So in terms of progress, you'll see, remember those targets, currently the target is 70% all the way through to 100% by 2030, and you'll see that for the last 5 or 6 years we've been tracking along this sort of 35, moving up. But there's a gradual increase taking place here. Everyone recognizes it's not as fast as we would like to see, but don't be put off by it either, just because it would be unlikely for that to say 70%, because that would imply all projects are meeting the targets, when that's not the case. The first thing to recognize, and that everybody recognizes, is that this challenge is essentially trying to transform the industry, and it's not going to happen overnight. but at least by reporting the data, we're able to see where we're at, and we're going to be able to, have more projects hit more of the targets and bring these numbers up. So we hope to see over the next few years these numbers starting to increase more rapidly. And we can talk a little bit about, some of the challenges with these, but this is essentially showing that the total portfolio submitted to the 2030 DDX in 2015, it was 38% above that original baseline. That's the average. There are many projects hitting the targets. There are some below that, but that's the average, and we can see that's what we're tracking as an overall roll-up. So it's okay, but we all recognize we could do a lot better, and the AIA themselves have been quite vocal in some of the things that we can do to do that, and we're going to share some of that information along with some of the findings of our own. So the other aspect of the 2030 commitment and the 20 is that people think of it as the goals, and they tend to measure their success or failure by whether they're meeting those goals or not. But in fact, another really important metric is, first of all, whether you're signed up or not. But then secondly, once you're signed up, are you actually reporting? So the other part of the 2030 commitment that it asks for is that in addition to trying to reach the goals, you're also requested to do annual reporting at a minimum. So that means for all your projects in your portfolio at all stages in the process, you report to the 2030 DDX. And you can see here there's room for improvement here. So again, in 2015, out of a total of 366 signatory firms, and you can see it's growing, right? There's even more firms added, 60 firms added in 2015. You'll see about half are actually reporting. So that's actually on the low side. There's significant room for improvement there, and we feel we understand a little bit more about why people maybe aren't doing that. And we'll share that with you. But as you can see, just on the reporting side, there's actually a lot more scope for improvement on the reporting side than there is on the target side. We want to see both move, obviously, but we could do a lot better job on having more firms reporting. The other key takeaway in the report, and this is a consistent finding year on year, is the difference in project performance that's observed when projects have an energy model created or not. And what you can see here is that, if you look at the legend here for percentage improvement above the baseline, you'll see that for start, there are no projects achieving even the top 2 tiers that are not being modeled. And they recognize that you absolutely have to be doing energy modeling early and often to achieve those, to have any chance of achieving those goals. And for the vast majority of non-model projects, they're in the lower category. They're basically just around code compliance, so that they're not really doing anything further than compliance requires. But modeling is really key to achieving these higher levels of performance. And as we're finding from a number of our customers, modeling is also the key to doing it in cost-effective ways as well. So it doesn't necessarily have to add to the cost of the building, because there are ways to achieve trade-offs in the design that can do that. So modeling is absolutely key. So much so that one of the key takeaways, and again, this is a consistent theme every year, but this is taken directly from the report. We didn't have to, change this because it speaks for itself. But basically, as you can see here, for any project of any size meeting the energy targets requires an energy model. There's no code equivalent that meets the targets. You must be building energy models early in the design process and design iteratively. They note that this year 59% of the total square footage of whole building projects had an energy model created, which is an increase, and that's good to see. It's good progress, but as you can see, it's not fast or not far enough. When we combine that as well with the fact that also, less than 50% of projects are actually being reported, there's very significant room for improvement. And in fact, we believe that the overall industry is doing better than that 38%, because not enough projects are being reported or modeled, because generally when you do some modeling, you can show a higher level of performance than code alone. It's very common for projects now to exceed code compliance. So we're losing that benefit in the data, and we're losing that credit to the industry, so to speak. So in addition to the annual report that the AIA have done, and as many of you may know, Autodesk have been strong supporters of the 2030 commitment, and we work with the AIA quite closely. understanding what it will take to get more people reporting, to do more energy modeling, make it a really integral part of the process. Of course, the annual report is a great resource for what's blocking the industry and how can we do better. But we took it on ourselves to do some customer research of our own. And essentially what we did was we reached out to each and every one of the 360 odd signatory firms. We contacted the people leading the 2030 commitment. Naturally, we couldn't get a hold of everybody. That kind of exercise is very difficult and time consuming, but we did speak to a large number of people leading these initiatives, and there's a number of key takeaways that we found from that. Many of them mirror, as you would expect, the annual report, but there's some interesting insights as well that aren't in that. So again, we see a very consistent thing that, again, less than 50% are doing the minimum annual reporting. That's not good. Less than 25% of that group are actually doing any energy modeling. Energy modeling was seen as a luxury, something that was only done on the largest projects, on the highest profile projects. And even then, it was not necessarily being done early enough to have a significant impact. Typically it's been done in detailed design for a sort of a code compliance checkbox, and it's not really been used to inform the design. So a huge amount of scope for improvement there, and it's a large part of what we're going to be talking about here today. The majority feel they're generally behind on the commitment. There's a sort of a degree of, should I say, sort of almost embarrassment about this, that we're not moving faster. Many people are doing great things, and there are some bright spots around certain people taking leadership positions on it, but the general feeling is, we're not moving fast enough, we're missing an opportunity, and we're behind on this. And there's an increasing anxiety, as time ticks by. We're into 2017 now, we're getting closer and closer to the next change in targets, and of course ultimately to the 2030 itself. So there's an increasing anxiety building around this, and certainly we're starting to see more interest and activity build up in this. But here's the really interesting part around some of the most common misconceptions. Both, some of these were in some of the individuals we spoke to, and also some of these were throughout the organization or the firms, and they were proving barriers to essentially taking part in this and doing this. The biggest concern was that the data is made public. To be very clear, it's not. Your data will not be made public. So if you submit your projects to the 2030 DDX, only you can see your projects. The only way that data is made in any way public at all is when the annual report is created, the overall roll-up of how we're doing, that percentage and number of projects modeled, et cetera, is all combined together. No individual firms are shown, no individual sort of locations are really shown to the level where anyone could see how one person is doing relative to the other, or how buildings are doing, or any proprietary building information. None of that is made public whatsoever. So the data is completely private, it's secure, and it's really there for you to take advantage of, to be able to see how your firm is doing relative to the rest of the industry, and also uncover some areas where you might be able to learn some lessons. So for example, one of the things that's been observed is that sometimes certain projects are seen, their performance starts off well and then drops off in certain stages, or alternatively, performance improves as the design progresses. So there's certain lessons you can see there, or maybe in certain markets or in certain building types you're doing better or worse relative to the targets. But again, unless we have the data, unless you're able to see where you're at relative to these benchmarks, you really don't know whether you're, just doing an energy model is not the answer. Just ticking the box, just reporting is not the answer. You need to be able to use this data to provide guidance for your firm and for your clients, and showing and demonstrating your capabilities in these areas. And so that was the other aspect. Really, many people are unaware of the value of the data. They see the reporting as a kind of a sort of a tax on, I must do this. It's sort of, a commitment. But others are finding a lot of value in that data. So, first of all, if you are reporting, make sure to look in and understand how you're doing relative to that. And the third one, and again, it's a real theme that we're going to be covering today, is that, and this is another really common one, is that energy modeling is very complex, very time-consuming, and even risky. And this is a well-understood sort of sense in the industry, not specific just to architects or anyone for that matter, but energy modeling typically is complex and time-consuming. And as for risk, is it really for the architect to be doing this type of analysis? What kind of what way does it expose you in terms of making commitments for certain levels of energy performance and so on? There's a lot of concerns around that, and as such, and there's been a lot of experience in the past with tools that have not worked out, have taken a lot of time, have yielded poor results, provided bad guidance and things like that. So there's a lot of kind of history there, and sort of negative feeling towards energy modeling as to being complex. And like I said, it can be, but it doesn't have to be, and especially not relative to the 2030 commitment. And especially if right now you're not doing any reporting, or you're not reporting on every project, there's opportunities to do significantly more, because the bar is not as high as it is for, take for example, creating a lead energy model. When you do a lead energy model, you have to provide very extensive reporting, very precisely and prescriptively defined, that a reviewer is going to carefully comb over to make sure you've measured the energy absolutely the way they intend you to do it. That's not the case with the 2030 DDX. It's up to really you and your project team, your client and your engineer to work together to state what you think these goals are, and have a common metric for driving the energy performance and managing the building energy performance. And when you remove yourself from those kinds of documentation type, code level documentation, you'll actually see that it can be a lot easier, and you can get as detailed as you want to be, but don't let the detail or the precision put you off from doing a certain level that provides a lot of value, which is really what we're going to share with you with Insight. So these were just some really key takeaways that we found from doing our own customer research, and we're continuing to always kind of like listen to our customers. And if any of you here have any particular nuggets of information you feel that are useful as the barriers of adoption for your firm, we'd be very interested in hearing that. So please do feel free to reach out to us, reach out to me, and I'd be interested in talking to you and hearing about that. Okay, so moving on. So based on all of that, obviously the nature of the webinar here today is to share with you how we think we can help with this. Autodesk Insight was designed for many things, but one of the things that serves extremely well is, of course, the 2030 challenge and the 2030 commitment, because essentially from an Autodesk Revit or format model, you can generate an energy model automatically, and then do very complete whole building energy simulation or analysis. I'm going to walk you through that today. In addition, there's one additional thing that helps you with the 2030 challenge and the 2030 commitment, in that we also have a link directly to the 2030 DDX. So if you're currently doing manual reporting, that takes time, and everyone's got to sort of do it through a spreadsheet or something like that. Here we have a way to directly link from your energy model for your project to the DDX, and I'm going to show you that here today. And so what it means within Insight, you can use Insight for doing the modeling, using it as a guide towards a better design, and with your project team to set targets and so on, as well as doing the reporting. And critically, now that we've removed that sort of manual step of reporting, which is generally reduced to annual, you can do it more regularly as well, which is really, really valuable, because you can get to see how you're performing at different design stages and with different projects. So you really get to see across your whole portfolio, not only projects in DD or CD, but for the whole life cycle, get to track projects and really dig down into that data on the DDX, because it's completely automated, and I'm going to show you that. Okay, so now we can get into our demonstration stage of the presentation. And as I said, we will leave time at the end for some Q&A. Okay, so the place I'm going to start is in Revit. Now, some of you may have seen a presentation of Insight before, but I'm going to go through it again for anyone who's new to it and not aware, because again, another thing we commonly found was that people were not aware of Insight, or if they've heard of it, they just thought it was just another name that we put on a tool we've had for a very long time. Insight itself is actually very new. It's only been out about 1.5 years. And it does present a very different paradigm to the industry, and fits very well with the kind of things you need to do for the 2030 challenge and the 2030 commitment. But I'm going to start in Revit. You could also start in Format, which of course is our conceptual modeler. But I'm going to use Revit because we can actually see the whole end-to-end workflow from conceptual to detailed. And what I actually have here is essentially 3 Revit models, and they're used to represent 2 things. One is the design process, going from that very early stage of massing through the schematic design, through the detail design, and also essentially 2 or 3 fundamentally different ways to represent a building for energy analysis. The reason I say that is that most people think of a Revit model as what's on the right-hand side here is a very detailed, rich, full building information model, and that's right. That's what Revit is for, design documentation and construction documentation. However, it can, of course, be used in a variety of other ways. It has the very powerful conceptual massing environment, and even from a conceptual massing model, you can very quickly start to skin out a building. So you've got great tools like things like wall by face, and curtain systems, and all that good stuff. Which I know if you're a architectural user, you'll know all of these things. But it's very quick to start to represent a real building. And in energy modeling terms, this level of detail of a building is more than what an energy simulation really needs. And you can very quickly start to represent it in this form. What we've got, of course, in Revit that supports Insight is the ability to automatically create an energy model from any Revit model, meaning we can go from conceptual all the way through to detailed. And because we're using the one model, we can track energy consistently throughout all phases in the design process. So if you start with something as simple as conceptual, and I'll show you how the energy model is created. But just to note, I'll show you how we can create an energy model from a detailed model. But if you've never created an energy model before on a brand new project and you've got this detailed model, there's 1 or 2 things you can do. You can create a detailed energy model, which can take anything from a few minutes to maybe a couple of hours. That's opposed to days and weeks for a traditional manual energy model. You can, of course, also create a very simple representation of the building. And people tend to not put a lot of value in these, but they're actually incredibly valuable because they can answer different questions about the building that this model can't. For example, if we were to sort of slope this wall in or out by 15 degrees, that would be a time-consuming manipulation to make in a Revit model. Whereas to do it in a massing model, we can do that very, very quickly. And because if I use both of these models, I'll actually be able to compare one to the other and essentially calibrate the one on the left to account for the detail that's in the one on the right, and use that to show me that impact of that sloping facade if that was a design question that we had. So again, I can model very flexibly from conceptual to detailed. I don't have to do that, but obviously this is the ideal way to do things from the very earliest stages. As you make particular decisions about the building, like this is going to have a feature elevation on it with some curved sort of architecture and curtain walling. At each step in that process, I can analyze this and see the impacts that it makes all the way through to detailed design. But of course, all of that, everything I've described, all relies on creating an accurate energy model. And all you need to do is in Revit, go to Analyze. You'll see a button called under Energy Optimization called Create Energy Model. It says delete right now just because my model is already created. And that will create a 3D energy model view, just like this one here, okay? And what you're seeing here is this is actually an energy model. It's completely automatically created. You do not author an energy model. You author an architectural model, and we automatically translate from that. And you'll notice what it's done is actually there's no glazing in this model, because glazing in itself is both a set of decisions you need to make as well as time-consuming to actually add to a model. And it's good to do the analysis even before you start to add any glazing to the building, because we'll analyze that in Insight 360 to see what opportunities there are and the impacts of putting glazing in different parts of the building. But basically what you'll see here is we've applied by default 40%. And also if we look top down, we've also automatically thermally zoned this building. So the standard practice that an energy modeler would take when you're at that early stage is to subdivide the perimeter from the core and then divide the perimeter based on each of the major orientations of the building so that the heat loss and gain is simulated correctly. So this is a very, very high quality energy model, all completely automated within Revit. Once we start to sort of articulate things on the building, like for example, if I put in curtain systems and walls and windows, like I have in this kind of schematic level model, and I've got pieces of the model like, where this wall sticks up and sticks over, I've got a roof parapet. These are all natural architectural modeling representations. In the past, an energy model, a manual energy model, would be a simplification of that building. And that's okay if you know what you're doing and because you're using it for comparative purposes. But if you've never built an energy model before and you're not sure what to do, then that presents a challenge, and that's always created a challenge in the past. That's not the case with Revit anymore, because essentially the energy model, again, is completely automatically created. So if you go to Analyze, you click on, again, Create Energy Model, and you'll get another 3D energy model view. And now you'll see in the energy model where in our physical model, if I just move this around so you can see it side by side. So if you'll actually see here, here, because on these, we've got some actual windows, we've got some curtain walling, we've got some, walls. The mass is still in there. It doesn't have to be, but that is actually still in there in this example. What you'll see now is that, now we've got actual analytical surface type windows. And here, for example, we've got where that roof parapet overhangs, you've got actual surface type shade, right? So that doesn't take part in heat transfer between spaces. It's essentially just causing shading on that roof. So at each time step in the simulation, depending on the angle of the sun, that roof parapet, wall parapet will be causing shading on that roof. Not a huge amount, but these are the little things that often get overlooked in a manually created energy model, and it can make a difference. And the difference being is that you're now getting pretty much a one-to-one takeoff of your physical model with really no simplification in between. And that would normally be extremely costly to do, impractical to do, so to speak, in traditional modeling tools. But it's not the case now because it's, again, completely automated. And again, it scales all the way up to a very, very detailed model. So now we're looking at, we've got every piece of detail we can think of in terms of, curtain walls and ceilings and shading and overhangs and, all kinds of stuff. And once again, it's very simple. You get a 3D energy model. And as you'll see, this energy model, I'm going to show you exactly what's in here. If we go into the model visibility and graphics, just turn off the architecture model, you'll see these two components under analytical model categories, spaces and surfaces. That's basically the anatomy of an energy model, those two things. Spaces are the parts of the building that are heated and cooled, and the surfaces are the paths of heat transfer between them. And basically that's what we'll see when we see in the energy model here. So this is a very, very accurate, geometrically accurate energy model. Accurate within a couple of percent. Normal manual modeling is typically accurate within around plus or minus 10% if it's a good model. And again, that's fine because it's used for comparative purposes, but this is normally within a couple of percent. And again, doing this workflow from conceptual to detailed, to create a massing version of a building, or even at the massing stages, you're talking really minutes to create a model like that. Energy model, completely automated. These kind of schematic level models can be created in, less than hours, to create the main places where you're thinking of putting glazing and so on. People don't usually think of Revit as a sort of conceptual schematic modeler, but for energy analysis purposes, it's extremely effective, very, very fast. So any energy modelers out there, where I'd really encourage you to take a look at this, or anyone who's currently using things like SketchUp or Rhino or anything like that, it's very easy to create a parallel model at this level of detail in Revit in order to do this analysis, all the way up through to detailed model. And of course, if you've been doing analysis throughout this process, by the time you get to here, there really is no work to do. However, if you're starting from this point, and invariably people are starting from some level of, design starting point, you can convert that directly, or you can do some parallel simple representations. Either way, energy modeling, the creation of an energy model should not take you long. Anyone who can do basic architectural Revit modeling can create a very high quality energy model. And all of this here is all very well documented online. It's pretty well, workflow orientated, and I would recommend you give it a go. I would always also recommend, don't necessarily start with your biggest, baddest, detailed design stage Revit model. The learning curve is going to be longer on that for you on the first time. Start with something smaller and simpler. And you'll get to understand the way the energy model is created and what you're looking at. And then there's essentially one of three workflows you can follow, all of which are detailed online, depending on what stage in the process you're at, and what your real target is and how much time you have, really. But like I said, it's anything from minutes to a couple of hours to create a very high quality energy model, all within Revit, all directly from your building information model. So there is no intermediate transfer and make any change at all. It's immediately captured. So that's essentially it with Revit for now, relative to just getting started with Insight. The only other thing that we ask we require you to do is, first of all, set the location. That's one of the known knowns in a building, in terms of, the location, and we have a wealth of climate data. We'll always pick the best available climate data that we have. We have all the industry standard climate data, along with climate data for every place on Earth at a 15-kilometer grid, as well as another service that provides us with climate data for any specific building location for any specific period in time, which is really good if you're doing existing buildings. But essentially, to make it simple for now, all you need to do is set the location. The only other thing you'll need to do specific to the 2030 challenge and the 2030 commitment is set the building type. which you'll find here, okay? So you'll see their building type. And the reason we say that's required for the 2030 challenge is that that's relative to a certain building type. The benchmark, which I'll show you later on, is relative to a certain building type. If you're just wanting to explore Insight, it's actually not necessary for you to set the building type because you can actually represent different building types in Insight itself. But for the benchmark to be right, you want to set that building type. No other information is required up front because every other piece of information that usually goes into an energy model, like the thermal properties of the walls and the space-by-space occupancy and lighting and things like that, all of that stuff that usually goes into an energy model actually is all varied in Insight. We actually don't just run a single simulation. We run a few hundred simulations on parameters that capture each of the major drivers of building energy. So then when we get into Insight, we'll be able to see how those things actually perform. And then we can come back to Revit and get more specific and see where the Revit model is performing relative to things. And that's where I'm going to go next. So essentially, once I've got my model and I've set my location and building type, all I need to do is click on the button Generate. That will send it to the cloud for processing. And you'll get an email saying that analysis has been received. And then you'll get an email saying that the analysis is complete. And depending on the model size and complexity and traffic on the server, it'll take anything from a minute or two to maybe an hour or two for a very large complex model. But you'll see that the wealth of information you get back is well worth it. We never hear from customers, or rarely ever hear, the processing time is a challenge for them because you don't need to do individual piecemeal simulations. That one simulation actually gives you the equivalent of billions of simulations, so it's very, very valuable. Okay, so from Revit I go into Insight, and notice, obviously I need to have Revit to generate the models, but if I'm working as part of an integrated team or with an engineer or with an owner trying to set goals, the fact that Insight is browser-based is really powerful because what we can do is we can add others to the Insight. So once you send these, they appear here in Insight. And I can add other people to this, and they can see it, they can interact with it, and it's a sandbox for them to understand the dynamics of energy. And it's much better than a static report because static report doesn't always capture the dynamics of decisions and operational uncertainty and things like that I'm going to get into. So what you can see here is that this is an Insight, and for each sort of stage in the process going from conceptual schematic to detail, this is essentially a kind of a simplified representation of that where I've got some early, mass modeling where I'm starting to sculpt the building form, and then I'm getting through to schematic design all the way through to detail design. And I can see and I can track performance throughout that whole process. I'm going to dive into just one of these so that we get to see the real core interaction model of Insight and how we get this cause and effect feedback and what we call outcome-driven user experience. Okay, so when you're looking at Insight, there's really three main parts. So first, you'll see the model view. So when I'm back in Revit, when I'm looking at, for example, this energy model in Revit, the energy model view, that is basically GBXML. That is the energy model there. But when I'm in Insight, I'll see a rendered version of it in the browser. My internet connection is going a little slow here today, so it'll come up in a minute. But here what we see is the energy cost range. We can use cost, or we can click it and we can use energy use intensity. There's different preferences for both. Naturally, the 2030 goals are based in EUI, but a lot of owners and clients don't actually understand EUI. Is 36 good? Is a saving of 6 good? But everyone understands running cost. So we like to leave the default as running cost because as you're driving one, you're driving the other as well. And at the moment, this is just an arbitrary starting point in this. But you'll see that we're showing the energy cost range to be 79 cents a square foot per year. We're currently hitting the Architecture 2030 challenge because you'll see that we're in green and we're below this 85-cent threshold. But you'll notice that the energy cost is actually a range. And this is really critical because although the single number provides a guide, it also shows you the remaining design opportunity and operational uncertainty. Because again, in energy modeling, it's typical to assume a single set of occupancy, a single set of set points and things like that, when in reality, the real building is going to vary. And also there might be decisions early on in the process that we haven't made yet, and we want to leave the door open for them. So the ability to recognize that energy is actually a range is really powerful, and then use that range to help guide decisions. So what I'm going to do is I'm just going to reset this just very quickly. Well, actually, I'll do it from here. But basically, yeah, so this is the energy analytical model. You can see how it's all comprised, the way it's broken up. This is a fairly standard Autodesk 360 viewer that we use. But if I scroll down here, you'll see that the building's energy use is broken up into a series of factors. So you've got big ones like things like building orientation, window-to-wall ratio on the south facade, shading on the south facade, glazing properties on the south facade. Same for north, south, east, west. Then you've got things like wall construction, roof construction, building infiltration, lighting efficiency, daylighting controls, plug loads, HVAC systems, operating schedule, and then finally photovoltaics, the amount of roof surface coverage that you've got, as well as payback limit and panel efficiency. What all of these factors basically comprise, it's pretty much a full landscape of all the key things that really drive building energy. And instead of simulating a single value, we've simulated a range of values. So take, for example, with orientation, the current orientation of the building, what we've got in the model is represented by this little triangle. So you'll actually see the current orientation of the building is actually bad. Right? It's actually, we're not achieving the target with that. But you'll see actually if we orientate the building at 180, which is the best, we'll see we actually achieve that target. We can see the worst is $1.05. But what we get is immediate cause and effect feedback. I don't have to go back, run a separate simulation, and do a manual comparison. Comparison is built into this. So in this case, we get to see the optimum orientation of the building. Granted, it's not always possible to change the orientation of the building. It's normally quite difficult to do purely for energy. But on the counter side of that, what you can do is be careful about where you place glazing, how much glazing you place, and the properties of those glazing. And that's really the purpose of these parameters here. So for example, you can see window-to-wall ratio. Here, once again, it's showing the 44% is where the model currently sits. So if we want to understand what, say, for example, we want big windows, well, once again, you're going to see that's going to have a very significant effect on building energy use. So moving from 44 to like 80, 90% is going to cost you 20 cents a square foot, increase of 20%, which is very significant when you were hitting the 2030 challenge. Alternatively, we could even improve our performance even further by reducing building windows further. So the critical thing to understand with Insight is not only are you testing what's put into the model, what you've defined in the model, but each critical driver we're testing across a range. And it's the slope of that curve that really drives things. So for example, if we've got very large windows, you'll actually see that the slope of the shading and the glazing properties will be very significant. Right? As you would expect, more glazing means it's going to have more of an effect. So notice here, exterior shading, if we were to add very extensive shading, would save us 30 cents a square foot, right? Whereas if I had the glazing that I actually have, right, like 44%, this is no longer, see, it's flattened out now, this is no longer going to save us 30 cents a square foot. It's now going to save us more like 13 cents a square foot. So it's all proportional and integrated. Almost every combination of parameters and factors that you can think of are calculated here. You don't have to do a sort of random trial and error one at a time. And critically, because we've got a range, the analysis is inherently more accurate because you're not assuming things artificially. Like, for example, the best example of that I can give is hours of operation. If you happen to know, the exact occupancy of the building and can predict it with reasonable accuracy, then you can do that. You can set it. You can add that data to the Revit model. Those kind of assumptions are very often made in most energy models, and one of the main reasons why energy models differ from the actual building energy. But what Insight allows you to do is not only document that, but also assume, hey, maybe there's some potential variation. Maybe you're sort of somewhere in that range, right? So that you're not going to exactly be 9 to 5 Monday to Friday. So again, that's allowing for a degree of operational uncertainty. And any decisions you make around optimizing the envelope or the lighting or anything like that, it's better if you optimize it for a range instead of optimizing it for a single point value. That's, again, another really critical idea in Insight that we use to help drive towards better building performance. So what you see here is pretty much a sandbox of all the critical driving factors. And what I can do is I can use this to navigate my way. So if I start from, say, essentially doing nothing, and notice I've got these bookmarked, all I need to do is click on any any scenario here, any setting of factors, I simply click this scenario button, and it will appear on the left-hand side here. So you'll see I did this one yesterday called Monday. If I add one now, right, you'll see it'll be called, I can call it, let's say, Tuesday, right? All right. And basically what this allows me to do is jump between different settings. So that's the mid-range. And if you watch the chart, notice now we're red because we're above 90.1. This is a significantly more poorly performing building. And the range is also much wider as well. And so this could be representing an old existing office or an old, badly performing school, or maybe just a current level of code compliance with some operational uncertainty in there. What I can very quickly do is I can look at different scenarios. This is what it would be if we improved the lighting efficiency. This is what it would be if we, change something else. And you see I've got these different bookmarks. This is where I was earlier on. And what's really nice is that within this I can do immediate comparison. And what this shows me is this is my path towards performance. It'll automatically rank them from the worst to the best. It shows my journey from essentially doing nothing or code compliance to upgrading the envelope to upgrading the systems to improving the operations all the way through to maybe adding some photovoltaic, and again in a very simple way on a sort of a percentage basis. We can see here at the moment there's 0 roof percent, but instead of having to actually physically model photovoltaics, I can go in and I can say, hey, there's 60% coverage, and that will have an impact on performance. You'll notice that will update straight away, and we'll see now, $2.20 change. So that's essentially the main components of Insight, and the whole idea is that from the very earliest stages, when you have something as simple as a massing model, without even any glazing applied, you can analyze that and you can quickly see the cause and effect of glazing, of shading, and of every other parameter. Then as you model throughout the design process and start to add specific glazing designs, you can measure that against your goals, continuously tracking, are you doing worse, are you doing better, all the way through to detailed design, where you're getting through to, even in Revit, if you desire, room by room and space by space lighting and occupancy and equipment, as well as individual thermal properties in the building elements. Notice in Insight we've got parameters for things like the overall, we're testing the overall value of all roof, or say all wall construction here, right? You see currently the BIM setting is in the middle, right? So we can very quickly see, hey, if we were to degrade that performance or if we were to upgrade it, you can see 20 cents of saving for the full range. But if I was to go back into Revit now at a DD stage and specify that to be an R60 wall and this to be an R60 wall, and even had maybe 3 or 4 different wall types in the building, all ranging from 50 to 60, what you would see then is that at a whole building level, that triangle will have moved over to the right-hand side, and then I can pick that and move forward. So again, we're always testing whatever the current design intent or idea is against a range of possibilities, so you can see how it performs, account for a degree of operational or information uncertainty, and always driving towards better performance. Okay, so that's essentially the main core aspects of Insight, and what I'm going to show you now is how you can use this to report to the 2030 DDX. So essentially, I'm going to go up one level here to what we call your insights. This is the model comparison. So one level above from this is essentially the gallery view and Insight. So you can use this to organize your projects by project or by project stage. It's entirely up to you. You can move things around. But once you're in one of these insights and you're able to see any model, you'll see this little button here. And it's got a number of options, like you can rename, you can move, you can do the retrofit analysis, you can export your GBXML, DO2. This is really good if you're working with an engineer who's doing maybe the co-compliance modeling or doing the detailed system simulation, which can work together really well, because if they create a separate model or they use this model, they can provide feedback into what other settings should be, like move the HVAC system factor a little bit to the right to get it calibrated to their model. So you can use the two tools in comparison. But the really important one here for us here today is report to the AIA DDX for the 2030 challenge. And it's really simple. At any project, at any stage, notice the name of the project Insight demo. We just click on report to DDX. Now, I should note, the first thing that you have to do is every firm has a 2030 DDX key. Right? It's like your own secret password and access to the 2030 DDX. If you don't have that, contact the 2030, the people at the AIA. You can get their email from the website. And basically you go into services, and then you enable the AIA DDX. I'm not going to show it because it'll show my key, but if I click on that button, it'll actually show you just 2 little pieces of data to enter, and then it'll connect to the service, and you're ready to go. Once that's done, set once, and it means anything you report from here will automatically appear in the 2030 DDX. So before I show you that, I'm going to show you the 2030 DDX itself. So this is the 2030 DDX. This has its own sign-in, and this is essentially a trial account that software developers can use. So none of this data is meaningful, but if you've seen this before yourself, you'll understand it. This is a list of projects, and I can see my overall sort of reporting and how I'm doing at a kind of a roll-up level. So this is really cool, right? This allows you to see, how you're doing overall. I notice here's a series of projects, and notice I've done this before, this Insight demo. I've actually submitted this project before. But the way to do it here, from here, and as I said, I can manually add projects here, I can manually update projects here, but there's duplication of work there and duplication of effort there. And at the moment, we find most people are only doing it at a minimum annually. And that's a challenge. The AIA are really encouraging people to report for the 2030 challenge a lot more often. But basically all I need to do is pick this and go report to the DDX. Okay, a little dialogue will come up and it'll give you your project name. If you haven't submitted it before, you can change it if you wish. You can specify the reporting year. You can specify the stage that you're at. It'll automatically pick up the location and zip and things like that. From the Revit model, it'll also pick up the building type, and you can set that specific to the 2030. It'll automatically report the baseline EUI, the lighting power, the occupancy sensors. There's certain data that goes into the 2030 DDX that allows you to see, some properties of that project, certain assumptions like the window-to-wall ratio. Look, there's the average window-to-wall ratio. There's the predicted EUI. Were daylight sensors included, and so on. And basically, all you do is click on send, and it will send that. Now, I'm not actually going to show this here, unfortunately, today, because actually right now, as it just happens, there's actually a problem with the service. It does happen from time to time with web services. Sometimes it's on our end, sometimes it's on the 2030 DDX. We're just looking at that now. But essentially what will happen is this little spinning wheel will happen. Oh, it actually worked. Somebody's been really fast and fixed that for me. So thanks, guys. So you'll actually see, and so if you notice now, I'm going to switch this to EUI because the 2030 is entirely in EUI. So we'll see 55.3. If I go over here now, I now refresh and look for this project called Insight Demo, you'll see it's 55.26. So let me just click that. Sometimes there's a little bit of rounding in the difference. And so now if I go in and change this project, schematic B, I assume I'm looking at the right one, but let me go in and say change it to higher performing option, right? So let's pick it to best. Okay, that's now 36. And another little view I can use, and I go report to GDX. So now we'll see it's 35.97, and I go send. And then I just refresh this, it should pick it up, 35.97. So you see it's automatically identified, picked that up, and done it for me. It's filled in all other available information. And if I do this on all projects throughout my firm at all stages, then I get to get the whole roll-up for my firm, and I can measure how I'm doing relative to how the rest of the industry is doing, as we see based on the annual report that the AIA produce. So anyway, I'm glad that's fixed because as luck would have it, just before this, I tried it and it wasn't working. It does happen from time to time with web services. We're continuing to make these things more robust, but as you can see, it was very quick to fix there, so it was even faster than I expected. But as we found this to be very, very reliable, the AIA have done a great job with the GDX API, and it's up like 99% of the time. So that's essentially it in terms of end-to-end with Insight or Revit to Insight to the 2030 reporting. I just have one slide I wanted to finish on here. So now that you've seen all that, what steps can you take? Very simple. If you're not already committed, then sign up. There's no cost to it. It really doesn't take anything else other than if you feel this is an important thing to your firm and to your clients, get signed up. Secondly, if you are already signed up or committed, one thing you can do is report more of your projects, right? And also report them more regularly, i.e. at different design stages. There's a lot of value in that. Also energy modeling, right? Do more of it. especially early and often. And I think, as I've shown you, Insight with Revit can really, really help you with that. It greatly lowers the barriers to doing energy modeling, and it greatly increases the quality of it because it removes the concerns about garbage in, garbage out because of its range-based approach. You can get a very reliable energy use intensity number, energy cost. And for more on that, we've got lots of good case studies and things that sort of demonstrate that. And then finally, use your data. There is value in it. If you start reporting, you'll start seeing what projects you're being successful on, what maybe locations and areas you're being successful on, what stages in the process are best, how are you doing overall relative. There could be some real value into it. You might find out, hey, you're doing really well relative to the industry, and that becomes a good sort of thing from a marketing perspective to start to promote that, as well as internally knowing how you're doing and starting to put initiatives in place to achieve this, and then to see, does it make a difference over time. So again, we're not going to know if we're doing better unless we get to measure things.